Hello everyone. In this video, we are going to discuss the second law of motion. So it is a line by line explanation. So let's start the video. The first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes. So this is the definition of first law of motion. That when you apply an external force, which is not a balanced force on an object, its velocity changes. That is, the object gets an acceleration. So we know that change in velocity is what we call as acceleration. So we would now like to study how the acceleration of an object depends on the force applied to it and how we measure a force. So what they are saying is we are going to study about the relation between the force applied and the acceleration of an object. That's it. So let us recount some observations from our everyday life during the game of table tennis. If the ball hits a player, it does not hurt him. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. So note this word, a table tennis ball will not hurt a player. But when a fast moving, note this word, a fast moving cricket ball hits a spectator, it will cause an impact on the person who got hurt by it. Then a truck at rest does not require any attention when parked along a roadside. But a moving truck, even at speeds as low as 5 meters per second, may kill a person standing in his path. Which means here also, a truck at rest does not create any impact on any, any other person. But even a small moving truck may create an impact on the person standing on its path. Then a small mass such as bullet may kill a person when fired from a gun. So in this above two examples, it talks about the velocity, and now it talks about the mass. A small mass such as bullet may kill a person when fired from a gun. So these observations suggest that the impact produced by the object depends on their mass and the velocity. Similarly, if an object is to be accelerated, we know that the greater force is required to give a greater velocity. So this is a general definition that we have to apply a greater force to change the velocity of an object. Then only it gets accelerated. In other words, there appears to exist some quantity of importance that combines the object's mass and the velocity. One such property is called the momentum, which was introduced by Newton. The momentum P of an object is defined as the product of its mass, m, and velocity. So P is equal to mv. Momentum has both direction and magnitude. Thus, it is a vector quantity. Its direction is the same as that of velocity. So direction of the momentum is same as that of velocity. And the SI unit of momentum is kilogram meter per second. Since the application of an unbalanced force brings the change in the velocity of the object, it is therefore clear that a force also produces a change of momentum. So what they are saying is how the unbalanced force changes the velocity. Like that, the force also produces the change of momentum. Let us consider a situation in which a car with a dead battery is to be pushed on a straight road to give it a speed of 1 meter per second, which is sufficient to start its engine. If one or two persons give a sudden push to it, hardly starts, but a continuous push over some time results in gradual acceleration of the car to the speed. So this is an example where your dead battery car is pushed to get it started. So a sudden push will not start its engine, but a continuous push will increase the acceleration gradually and its speed will start to increase. So it means the change of momentum of the car is not only determined by the magnitude of the force, but also by the time during which the force is exerted. So the change of the momentum is not only depend on the force, but also during which the time the force is exerted. It may then also be concluded that the force necessary to change the momentum of an object depends on the time rate at which the momentum is changing. So to change the momentum, there must be force. Now this force is depend on the time rate at which the momentum is changed. The second law of motion states that the rate of change of momentum of an object is directly proportional to the applied unbalancing force in the direction of the force. This is the definition. So rate of change of momentum is directly proportional to the applied unbalanced force in the direction of force. So these are all theoretical concepts about second law of motion. Let's see the mathematical formulation of second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity d in time t by the application of a constant force f throughout the time t. The initial and final momentum of the object will be. So p1 is the initial momentum. That means when the car starts accelerating, that is p1 is equal to mu, and p2 is the final momentum, that is p2 is equal to mv, where u and v is the initial and the final velocity. So the change in momentum is directly proportional to final momentum minus initial momentum. So p2 minus p1, that is p2 mv minus p1 mu. Take m as common, we get the expression m into d minus u. Since we know that it also depends on the rate of change of momentum, then the rate of change of momentum is directly proportional to m into v minus u by t. So from the Newton's second law of motion, the force applied is directly proportional to the rate at which the momentum is changed. So we can write this expression as F is directly proportional to m into v minus u divided by t. So F is equal to k m into v minus u by t. What is k here? K is the constant of proportionality. So F is equal to k into m into a. Why a? A is the acceleration. So what is acceleration? Here look at this expression. This is change in velocity with respect to time taken. So we can denote it as acceleration. The SI units of mass and acceleration are kilogram and meter second power minus 2. The unit of force is so chosen that the value of the constant k becomes 1. 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second minus 2 in an object of 1 kilogram of mass. So we define the unit of 1 unit of force, which is equal to k into 1 kilogram into 1 meter second power minus 2. Thus the value of k becomes 1. So F is equal to mv. The unit of force is kilogram meter second power minus 2 or Newton, which has a symbol n. The second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. The second law of motion is often seen in our everyday life. So let's step into the real example. Have you noticed that while catching a fast moving cricket ball, a fielder in the ground gradually pulls his hands backwards with the moving ball? In doing so, the fielder increases the time. Yeah, this is very important. The field is actually increasing the time during which the high velocity of the moving ball decreases to zero. Since a moving ball has some velocity and its velocity will get decreased until it reaches the hands of the fielder. So the fielder, that's why, moves his hand backwards to reduce the impact. Okay. So during which the high velocity of the moving ball decreases to zero. Thus the acceleration of the ball is decreased. Therefore, the impact of catching the fast moving ball is also reduced. If the ball is stopped suddenly, then its high velocity decreases to zero in a very short interval of time. So that is why the time is very important. The rate at which momentum is maintained is very important. So if the ball is stopped suddenly, its high velocity decreases to zero in a short interval of time. Thus, the rate of change of momentum of the ball will be large. Therefore, a large force would have to be applied for holding the catch that may hurt the palm of the fielder. In a high jump athletic event, athletes are made to fall either on the cushioned bed or on a sand bed. This is to increase the time of the athlete's fall stop after making the jump. So this is also a real life example. This decreases the rate of change of momentum and hence the force. Try to ponder how a karate player breaks his slab of ice with a single blow. This is an activity. This image shows that how the fielder moves his hand backwards to catch a fast moving ball. The first law of motion can be mathematically stated from the mathematical expression for the second law of motion, that is F is equal to ma. F is equal to m into v minus v by t, and ft is equal to m. This goes opposite side. So ft is equal to mv minus mu. That is when force is equal to 0, v is equal to u for whatever time t is taken. This means that the object will continue moving with uniform velocity u throughout the time t. If u is 0, then v will also be 0. That is, the object will remain at rest. So these are all about second law of motion. Hope this video is helpful for you. In the next video, we will discuss another topic. Thank you.